Hi everybody. Now we will perform another experiment that is a part of this DNA recombinant techniques, and this is known as ligation. Contrary to the other one that we did before, in this case we are not going to break phosphodiester bonds, but we will create them. For that, we will use a piece of DNA and that has been digested, and then we will religate and form again that piece of DNA in certain form.
Okay, so as mentioned, today's going to be the opposite of the last experiment that we did, where instead of taking a single piece of DNA and digesting it, breaking it into components with restriction enzymes, we're going to use smaller pieces of DNA and use a new enzyme called ligase to stitch them back together into a single piece of DNA. So the DNA we're using today is known as lambda phage, and it's the genomic information from the lambda virus. Now, we're not using live virus. It's perfectly safe to use. It's just the DNA from it. And specifically, we're using lambda DNA that's been treated with HinDii, Hindii. HinDii is a restriction enzyme that will target multiple cut sites in the lambda DNA. And this is because the site that HinDii recognizes is simply found in multiple locations in the lambda genome. So if we take the single piece of lambda DNA, which has a couple different cut sites in it, and treat it with HinDii, we end up with these specific cut pieces. Now, what we're going to be doing today, and this is what we're starting with a solution of lambda phage that's been already digested. We're going to be treating it with the enzyme ligase that will take all of these pieces and combine them back into a single piece. Now, what's important to remember is that all of these cut sites come from the same restriction enzyme, HinDii. So if we were to actually number these segments, let's say 1, 2, 3, 4, 5, 6. And here we have those segments. Each of these segments has the same ends of the DNA. So once we take an enzyme like ligase to recombine them, there's no guarantee at all that this enzyme will put this molecule back together in the same order. So, maybe some of the pieces will be 1, 2, 3, 4, 5, 6. Maybe some of them will be 1, 3, 5, 4, 2, etc. It's also possible we may end up with a piece that is 1, 1, 1, 1, 2, 1. This is basically going to be randomly reassembling our different pieces into a single molecule.
And in fact, we can even have shorter fragments too, because, depends how long you leave this reaction. You can have a fragment that is going to be only 2 pieces, 1, 2, 3, 4, 1, 2, 3, 4. So, it's going to be a big mix, depending on the time and how much ligase you add to the reaction.
Now, what today's experiment is going to be looking at is going to be the ligation under 2 factors. One is going to be the concentration of ligase. We expect the higher amount of enzyme present, the faster the ligation will occur, and also ligation over time. As we incubate this 25 microliter reaction, we're going to be taking aliquots, taking fractions of our total amount after everything's been added every 5 minutes, and we're going to be stopping it. That way, we can visualize the ligation process over time, and we can see that as the incubation period gets longer, as the reaction sits for a longer period of time, we will go more and more from the individual cut pieces, and we'll see less of these to seeing more single pieces that are put together.